CircuitPython Parsec today, I want to show you how you can use the Wii controller as an input for graphics on a microcontroller with a display. So in this case, I've got a Feather RP2040, and I'm using this really cool sharp memory display. I've got an official Nintendo Classic controller with our little breakout, because these are I2C. And you can use the very classic Wii controller or any of the other gizmos that have that proprietary Nintendo wiichuk adapter that happens to be I2C. And the way that this works is I've got it set up right now so that I'm moving this little vector I/O dot around the screen using the D-pad on the controller. I can press buttons to recenter that if it's disappeared off the screen. And I can also press the A button to double the size of this sphere here. I'm not doubling the speed, so it kind of moves around a little more, looks a little more loafy now. So the way this works in CircuitPython, you can see here, I'm importing some libraries, the time board for some pin definitions, display I/O, frame buffer I/O, vector I/O for that fast drawing circle on there. The Adafruit Wii Classic library allows me to use this and other Nintendo wiichuk adapted controllers, as well as the display shapes rectangle to draw the white background, and the sharp display library for this sharp display. We release the displays to free up any resources, and then I'm using the SPI bus to connect to this display, and then setting up a frame buffer that's 400 by 240 for that display, and creating the display object. Then I'm initializing I2C as the board stemma I2C, where I have that adapter for the controller plugged in, and creating the control pad object. And then we throw up the background, create some colors for palettes, set the size of the dot, as well as how fast it moves by step size, which right now I have just a little bigger than the diameter of this sphere or this circle, so that it moves pretty fast but is still smooth looking. And I'm also setting that initially to the center of the display just by dividing the width and the height. Then we create the palettes and the dot object with those settings. And then in the main loop here, you can see I have this variable for state called moved, and that just checks to see, has any of the D-pad direction buttons been touched? If so, then we can update the X and the Y position of the dot. The reason that we don't just directly move those is I want to avoid stair-stepping when we go diagonally. So we look to see what's changed, and then when we know which, it could be up and left, have changed, then we apply those to the actual XY coordinates of the dot. So we check that for up, down, left, and right, and you can see I'm moving that based on that move step size that I set up earlier. So then if moved state has been updated to true, then I set the dot X position to that variable and the dot Y position to that variable. And then for the circle to return to the center, I've got this the B button. So when I press B, we're going to set that back to the display width and height that it was originally at, sort of center of the screen. When I press A, while that's being held, double the size, and then when I release it, we go back to the original size. And we can still move while we're big like that, as I showed before. This is if we're trying to move and center ourselves. It's just fighting back and forth between those. And so that is how you can use the Wii controller as an input for graphical update inside of your CircuitPython code. And that is your CircuitPython Parsec.